Margin of error and estimates. A point estimate is a single value that has been calculated from a sample data to estimate the unknown population parameter. So when we're working with populations, we use a P when we have a population proportion, mu for population mean, and sigma for population standard deviation. The corresponding sample statistics are P hat for the sample proportion, X bar for the sample mean, and S for the sample standard deviation. We're going to use estimation based on sample statistics for our populations. An estimation is really a guess, however, it's not random, it's based on our sample values. Suppose we'd like to make an estimate of a population parameter based on a sample statistic. A confidence interval gives us a range of possible values that is likely to contain the unknown population parameter that we are seeking. First, we must have a level of confidence, say 90% or 95%. Then, based on this level, we'll compute what's called a margin of error, and we'll discuss how to actually compute our margin of error in the next few sections. It's based on several factors, such as are we working with means or proportions, and what is our level of confidence, and what type of distribution are we working with. Last, we can say that we are, whatever our level of confidence is, percent confident that the true proportion parameter falls within our confidence interval. The formula for a confidence interval is our sample statistic plus or minus our margin of error. For example, suppose the heights of the population of the basketball players at a certain college are in question. A sample size of 16 is randomly selected from this population of basketball players and their heights are measured. The average height of this sample is 6.2 feet, and the margin of error is found to be 0.4 feet. If this margin of error was determined with a 95% confidence level, find and interpret the confidence interval. We take our sample statistic 6.2 and we will add and subtract our margin of error. That gives us a confidence interval of values from 5.8 to 6.6. What this means, how we would interpret it, is we would say that we are 95% confident that the true mean height of all basketball players is between 5.8 and 6.6 feet. So what does this interpretation really mean? Well, a 95% confidence level would mean that if I take 100 samples, then about 95% of them would contain the true mean. Here's an example where I've taken 10 samples, and about 9.5 of these 10, and really in this example 9 of these 10, contain the true population mean.